Hungarian method for solution of assignment model. Right, so it is Hungarian method for solution of assignment model. Right, so very simple steps are there. I'll be after that you yourself can think of framing an algorithm for this, but as of now we'll be solving the numerical, and then we'll be writing, after solving of one numerical, we'll be writing the algorithm. So just a minute, let me think of it. Okay, we'll be solving numerical only, and then we'll be writing the algorithm, so that it will be easy to understand, because we both can't we can't go in a parallel way. If it would have been a classroom, it would have been easy for to go in a parallel way, but at this particular juncture, it is not feasible to go in a parallel way. So let's solve it by let's solve the assignment problem. So I'll be telling you what are the steps that we need to do. We'll be doing all those steps, and right, in tomorrow's or in the next lecture when we'll be meeting, what we will be saying is that how to write the algorithm, right? So we are going to frame out the algorithm, provided you understand and remember today's numerical, how we are solving. And in that lecture we'll just frame out the algorithm, so that if you read that algorithm, anyone who will be reading that algorithm will be able to understand how the assignment problem is to be solved. We'll be writing it in that simple language, right? So let's solve the numerical. We have a numerical as solve the following assignment problem. Right, so the assignment problem is given to us in a very simple format. One, two, three, four, five. Right. So there are five operators that we have, and we have 5 jobs. So we have to decide which job is to be given to which operator, depending upon the extra data that has been given us, that is the effectiveness of each operator on each job. So the values that we have are 9, 11, 14, 11, 7. It is 6, 15, 13, 13, 10. It is 8, 8, 6, 13, 12. We have 11, 9, 10, 12, and 9. And nextly, we have 7, 12, 14, 10, and 14. Right? So these are the values. You can say that this is the time in minutes that these operators take to complete that particular job. So now let me write that thing as well. So the operator's effectiveness in minutes for all jobs is represented in matrix above. Okay. So what they have told us to solve the following assignment problem. So this will be what it will be. At a glance only, you should be understanding that it is a minimization problem, in which the assignment of job to an operator is to be done in such a manner that the total time will be less. So the total, lastly, the total time after the assignment should be less, right? So now what we have is the very first thing is that we have to go for row and column reduction, right? So all these steps are very easy, provided you remember what are the steps to be done and what you have to do properly. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? So it is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now what we are going to do firstly is the row reduction. Right? So no, because of a space constraint, I am drawing. I'm going to solve it on in a parallel way, but you will have to solve it on a page in a proper step-by-step format. So now the first step is the row reduction. So in row reduction, what we are going to do is we are going to identify the value which is having least cost for every cell. Okay. So now, for example, in row number 1, if you see, so the row minimum value here is row minimum value. So the row minimum value here is 7. Here it is 6. Here it is again 6. Here we have the value as 9, and nextly we have the value as 7. After identification of this row minimum value, what we are going to do is we are going to subtract all these values from the respective cells of that row, right? For example, 9, this 9 minus 7 will be equal to 2. 11 minus 7 is equal to 4. 14 minus 7 is equal to 7. 11 minus 7 is equal to 4. And 7 minus 7 is equal to 0. So this is, we have reduced our first row, right? Nextly, same thing we are going to repeat, but here the values for the row 2 will be considered, and the minimum value considered will be 6. So 6 minus 6 is 0. 15 minus 15 minus 6 is 9. 13 minus 6 is 7. 13 minus 6 is 7, and 10 minus 6 is 4. Right? Similarly, reduce to row 3, row 4, and row 5 as well, with the respective values and the respective row minima values. So nextly for row number 3, 12 minus 6 is 6, 13 minus 6 is 7, 6 minus 6 is 0, 8 minus 6 is 2, 8 minus 6 is 2. Similarly, for row 4, that is the row minima value is 9. So 11 minus 9 is 2, 9 minus 9 is 0, 10 minus 9 is 1, 12 minus 9 is 3, and 9 minus 9 is 0. Lastly, we have the value, for row 5, the row minima value is 7. So 7 minus 7 is 0, 12 minus 7 is 5, 14 minus 7 is 7, 10 minus 7 is 3, 14 minus 7 is 7. So this is the row reduction that we have done. Right? After row reduction, what we are going to do is, after row reduction, we are going to move towards the column reduction. Right? So the next step that we have is a column reduction. Right? So we are going for column reduction now. Now for the column reduction, we will be having, right? So for the column reduction, we'll be having the value, the matrix which is to be considered is this matrix, which is which has been the row reduction has been done in this matrix, not the previous that has been given in the numerical, right? So now we'll be doing the column reduction. Now, the minimum value in column number 1 is what? It is 0. Right? In column number 2, it is again 0. Column number 3, it is again 0. And in column number 4, no, there is no 0, but there is a value that is 2. And in the last column, the minimum value is 0. Right? So we'll have to do the column reduction same as that we have treated the row reduction. So 2 minus 0 is 2, 0 minus 0 is 0, 6 minus 0 is 6, 2 and 0. Right? Because the minimum value is 0, the same value we will be getting. Here also it will be the same values, 4, 9, 7, 0, 5. Next is 7, 7, 0, 1, 7. Now here we'll have some different value. 4 minus 2 is 2, 7 minus 2 is 5, right? 2 minus 2 is 0, 3 minus 2 is 1, 3 minus 2 is 1, right? Nextly, we will be having same values 0, 4, 2, 0 and 7, right? So this was the column reduction, right? Now, why we have did column reduction and row reduction, I'll be telling you the philosophy or why it is to be done, or what we are going to check. Now, after doing the row reduction and the column reduction, we are what we are going to achieve with this is that in each row, after the column, after the row reduction, after row reduction, in row reduction, what we have done, we have made 0 to appear, at least 1 0 to appear in every row. If you see the row reduction matrix, there is at least 1 0 in every row. So if you check row number 1, we have 1 0. Row number 2, row number 1 we have 1 0. Row number 2 we have 1 0. Row number 3 we have at least 1 0. Row number 4 we have at least 1 0, and row number 5 we have at least 1 0. Right? If we had a column, if we why we have did column reduction, because we have to make sure that at least 1 0 appears in every column, right? So here there is 1 0, here there is at least 1 0, here there is at least 1 0, here there is at least 1 0, and here also there is at least 1 0. Now, why it is important, why it is to be done is that you will be understanding in the next step. I'm hoping that you have got this. We have understood what is row reduction and what is column reduction. After row reduction and the column reduction, you have to ask yourself, or you have to check whether there is at least 1 0 present in every row and every 1 0 present in every column, right? We would have stopped at row reduction matrix only. But what has happened in row reduction matrix, we didn't get 0 in one of the column, right? So to achieve that, we have done the column reduction. But anyway, you do irrespective of the column appear, the 0 appears in column or not. After every step, after the first step should be row reduction and the next step should be column reduction. Remember that for every assignment problem, you'll have to go for the row reduction first and then the column reduction. Now, firstly, we had a numerical, and on this numerical matrix we were operating, right? So after operating, we got a row reduction matrix. After operating on row reduction matrix, we got a column reduction matrix, and now we are going to operate on column reduction matrix. I'm just going to copy the column reduction matrix on my next page, and then we'll be using this column reduction matrix for the further use, right? So just a second, let me copy this, and then we'll be moving ahead. Right, so it is 24720 09754. Then we have 67002. We have 20110. Nextly we have 05717. Right, so this is the column reduction matrix that we have obtained. Now what is the next step that we have to do is that we have to pass the minimum lines, cutting all these zeros. So we have to cut all these zeros. So we have to pass minimum lines which are going to cut all these zeros. Now it is when I say that the minimum lines, then the thought comes, how we'll be deciding the minimum lines, or maybe we can make some mistake while cutting these zeros, and it may so happen that we don't get the minimum lines, or one of the one line is extra in our case. But the that for that particular that also we have a procedure. So what we are going to do is, on the row, on the column reduction matrix, we are going to perform the row scanning. Firstly, we are going to do the row scanning, and then we are going to do the last scanning, the column scanning, to achieve the minimum lines that cut all the zeros in the matrix. So let me tell you how we are going to do the row scanning, right? So now firstly, for the row scanning, what we are going to do is that we are going to consider each row starting from top to bottom, right? So, for example, 1, 2, 3, 4, 5. So we'll be starting with row 1 and then we'll be moving towards row 5, right? Now, while doing the row scanning, consider row number 1 and ask yourself a question. Is this row contains only 1 0? I'm repeating it again. Is this row 1 consisting of only 1 0? If there is only 1 0, then only we are going to proceed. If there are multiple zeros or more than 1 0, we are going to skip that row, right? So now ask the question, if the row 1 consists of only 1 0. If it consists only 1 0, then make a square around that particular 0 and draw a vertical line passing through that 0. Right? I'm repeating the statement. Scan row number 1 and ask yourself a question. If that row consists of 1 0 only, if the answer is yes, right, make a square around that 0 and draw a vertical line passing through that 0. Right? Now we are going to proceed towards row 2 and we are going to ask the similar question. Is that row consisting of only 1 0? Yeah, the answer is yes. So we'll be making a square to this row and again we are going to draw a vertical line. Right? We are going to move to row number 3 and we are going to ask ourselves if it has only 1 0. The answer is no, it has 2 zeros and we are going to skip that row, right? We are going to move towards row number 4 and now we are going to ask ourselves if it consists only 1 0, right? So if it consists only 1 0 because the other 0 has got cut, right? So here it has only 1 0. We are going to make a square around that 0 and we are going to draw a vertical line passing through that 0. Lastly, we are again going to ask the same question to row number 5. Is there only 1 0 present? Yeah, there was 1 0, but it got previously cut. So there is no zero here, and we are going to stop the row scanning. Right? After row scanning, you will be you'll be asking yourself if all the zeros in the matrix are cancelled or not. If after row scanning, if some zeros are remaining, you'll have to proceed towards column scanning. If there are no zeros, then it is okay, right? We'll be moving towards next step, right? But here we have some zeros remaining, and now we are going to do the column scanning. So column number 1 is already been cut. Column number 2 is already been cut. In column number 3, we are going to ask the same question. Is this column, is there only 1 0 in this column? If yes, we are going to mark a square around that particular 0. And here, what we are going to do next is that we are not going to draw a vertical line. We are going to draw a horizontal line. Right? After finishing entire, next thing is now that, if you see, all the zeros have cut and we have the lines passing through 0. So we have achieved our objective of passing minimum lines that cut all the zeros, right? So if you see, if you look out to this, the matrix that we have got, here we have touched all these zeros and we have cut all the zeros with the minimum possible line. So we have 1, 2, 3 and 4 lines that we have used for cutting the zeros. Right. So now the next step is that after this particular step, we'll have to check for the optimality. Check for optimality. Here we are going to check. The optimality check is very, very easy. Number of allocations or number of assignments, what we'll be saying, number of assignments is equal to. So all these squares, all these zeros for which we have done these squares are our assignment. So here we have 1 assignment, here it is 2, here it is 3, and lastly we have 4. So number of assignments is equal to 4 and number of rows is equal to, we can say number of rows or number of columns, doesn't matter, it is going to remain same. So number of rows is equal to 4. So if number of assignments is equal to number of rows, the optimality is okay and the obtained solution is an optimal solution. If number of assignments is not equal to the number of assignments is not equal to the number of rows, then what will happen is that the obtained solution is not an optimal solution and we'll have to iterate further. So as 4 is not equal to 5, iterate further or proceed further. So for the for the above for this this particular solution is not an optimal solution and we have to move ahead. So the reference solution or the solution on which we are going to do some process is this particular solution, right? So in this particular in this solution we are going to do some process to make it optimal. So what we are going to do is that we are going to identify the the right word is identify the cells which are undeleted. Identify the cells which are undeleted, deleted, and amongst them identify a cell with least value, right? So we are going to identify a cell, undeleted cell with the least value. The undeleted cell means the line is not passing through that particular cell. For example, 7, this cell 7, 2, 7, 5, 1, 1, 7, 1. These are all undeleted cells because the lines are not passing through them, right? So identify the cells which are undeleted and amongst them identify a cell with the least value. So the least value is what? The least value that is we have got is 1. So add the least value to the cells where intersection of lines happen and subtract the least value from all the undeleted cells, right? So what we are going to do is that we are going to I will be drawing this solution again, right? Because here we have made a lot of overlap, lot of overwriting. So I'll be rewriting this and then we'll be using this logic. I'll be making you understand this logic. Just a second. Two, 4, 7, 2, 0, 0, 9, 7, 5, 4, 6, 7, 0, 0, 2, 2, 0, 1, 1, 0, and 0, 5, 7, 1, 7. So previously we did some here the allocations were done. So same solution I'm drawing, just a second, right? So third we didn't do, here we had a solution, lastly we had a solution, right? So this was the answer that we have. Now what we are going to do from the undeleted cells, we are going to identify the cell which is having the least value, which is 1 that we have identified, right? Now we have to add this value at the cells where intersection of lines has happened. So intersection of lines has happened in this particular cell. In this particular cells, here you can see the horizontal and vertical lines intersecting each other. In this cell, and in this cell, the intersection has happened. In all the other cells, the intersection didn't happen, right? So in these 3 cells, we are going to add that least value, which is 1. and we are going to subtract the least value 1 from all the other undeleted cells only. So the undeleted cells are 7, this cell 7, 2, 7 and 5. 1, 1, 7 and 1. All these are undeleted cells, and from this we are going to subtract the value of 1, right? So let me draw that cell again. Right. So now we'll be focusing on firstly on the intersected cells. So this is 6 plus 1, that is 7, 7 plus 1, that is 8, 2 plus 1, that is 3. The undeleted cells, firstly 7 minus 1 is 6, 2 minus 1 is 1, 7 minus 1 is 6, and 5 minus 1 is 4. Similarly here 1 minus 1 is 0, 1 minus 1 is 0, 1 minus 1 is 0, and 7 minus 1 is what it is? 6. All the other cell values will remain same. 2, 4, 0. Here it is 0, 9, 4. Here it is 4. It is 0, 0. It is 2, 0. Here it is 0. It is 0, 5. And here lastly is 7. So all the other values remain same. Now when we will be achieving this particular solution, again what we are going to do is row scanning and column scanning. Row scanning, and if it is needed, then we are going to go for the column scanning. Let's go and start with the row scanning. In row scanning, ask yourself a question for row number 1. If you have only 1 0, if yes, put a square into that 0 and draw a vertical line. Right. Similarly, for row number 2, ask yourself if there is only 1 0. Yeah, we have only 1 0. Mark a square around it and draw a vertical line. Right. After that, we are going to ask to row number 3 if there are only 1 0 in it, and the answer is no. So we are going to skip row number 3. For row number 4, again we are going to ask ourselves a question. If there is only 1 0, the answer is no. We are going to skip. For the last row number 5, if we are going to ask if there is only 1 0, yes, there is only 1 0 here. And what we are going to do is we are going to make a square mark, and we are going to delete this entire. We are going to draw a vertical line. After doing so, we are going to check whether all the zeros are cancelled or not. If with the help of row scanning all the zeros are cancelled, there is no need of column scanning. But here you can see that few of these zeros are still pending, and what we are going to do next is that we are going to do the column scanning. So the next step is the column scanning, right? So for the column scanning, again we are going to ask ourselves a question. If there is only 1 0 in the if there is only 1 0 in the column, right? So column number 1 is already cut. In column number 2, we are going to ask the same question. Yes, there is only 1 0 that is with us. We are going to put a square mark, and we are going to draw a horizontal line. This is very important. We get into a habit of drawing only vertical lines. So appropriate verticals and the horizontal lines are to be drawn. Then only the numerical will solve. Otherwise, you will be moving in a circle, and the easy numerical will remain unsolved. Right. So now for the row column number 3, we are going to ask the same question. If there is only 1 0, yeah, there is only an 1 0. So we are going to put a square mark, and what we are going to do next is that we are going to draw a horizontal line passing through that 0. So now you can see that here, if you put a glance on the solution, all the zeros have been cut. So now this is the new solution. We are going to check for the optimality. Check for optimality. Right? Number of allocations. Number of allocations is equal to how many? we have 1, 2, 3, 4, and 5 allocations, and number of rows or columns is equal to 5. So no, 5 is equal to 5. Hence, optimal solution is obtained. Hence, the optimal solution is obtained. Now, what is the solution? Right? So we have made the squares, we have done cancelled everything, all the cells appear to be cancelled. What is the optimal solution that we have received? So now your this was job and these were your operators, right? These were all your operators and these were all your jobs. So now job number one is being allocated to operator number 5. The answer is this. So your job number 1 gets allocated to operator number 5. Your job number 2 gets allocated to operator number 1. Your job number 3 gets allocated to operator number 3. Your job number 4 gets allocated to operator number 2, and your job number 5 gets allocated to operator number 4. Right? We can also find out what is the time. So for the time you will have to refer to the initial given matrix in the numerical. Many of the students make a mistake, right? So the time that will be required, that will time that we are going to refer in the solution is to be referred from the numerical which is given as which is the numerical which is given in your question, right? Or the values that are going to get from your question. So let me write the solution in a proper format. Therefore, the optimal solution, hence we can write, hence optimal solution obtained. Optimal solution obtained is as below. Right? So we have job, we have operator, and the corresponding time for a operator that complete that particular job is always to be written. Right? So 1, 2, 3, 4, 5. So first number job is given to operator number 5, who can do it in 7 minutes. Job number 2 is given to operator number 1, who can do it in 6 minutes. Job number 3 is given to operator number 3, who can do it in 6 minutes. Job number 4 is to be 4 is given to operator number 2, who can do it in 9 minutes, and job number 5 is given to operator number 4, who can do it in 10 minutes. So this is how you should represent the answer of the assignment model. So which facility is to be assigned to which job or which service, that is to be tabulated, and across it the time parameter is to be written.